Continuing along, now we've done the first couple groups and we're moving on to a new rule. The new rule has to do with dividing, and what do we do with exponents? Well, just like before, the bases have to match up in order to do division. So, well, we can look at something like x to the 6th over x to the 3rd. That's the type of problem that we're going to be looking at doing with this quotient rule. Well, let's think about this. When we did products or multiplication, what did we do to the exponents? We added them up. Well, we're going to be doing the reverse here. We're going to be dividing, so we're going to do the reverse to the exponents. We're going to subtract them. So what we'll do is, just like before, the base will stay the same. The base is x. So the x and x, the base stays the same as x, and you'll subtract the exponents. So 6 minus 3 is a positive 3. So we get a positive x, or we get an x to the positive 3rd. Now, to see why this works, let's take that same example and kind of work it out a little bit more in detail. And here's the idea. It's because on top, when you have the x to the 6th, if you were to write that out in detail, you get x times x times x times x times x times x. And on the bottom, the x cubed would look like, well, that's 3 x's, x times x times x. Now, if you remember your rules, when you are reducing fractions, you can reduce anything from the top and the bottom as long as they match exactly. So that means I can cancel out copies of x between the top and the bottom. So I can cancel out 1, 2, 3 copies of x, which leaves me with 3 copies of x left, which means that would be the same thing as saying x to the 3rd. Notice we get the same exact answer. Notice when we were subtracting the exponents, we always take the one that's on top minus the one that's on the bottom. That is important because sometimes we're going to end up with negative exponents. So had I flipped this upside down, and I'm going to go up a little bit here, and did x to the 3rd over x to the 6th, doing the shortcut, what we would have gotten was, well, the base stays the same, so the x's stay the same, just like in the last one. So you'd have your base of x, but this time when you subtract, notice what happens. You'd have 3 minus 6. Well, 3 minus 6 is actually a negative 3. Well, what happens to negative exponents, we just covered this, is the negative exponent means that this piece would drop down to the bottom and become x to the 3rd. And you'd have your hidden 1 on top. That's why we covered the negative exponents first. Now, if you do it more of the by hand way we were just doing it, we have 3 x's on top and 6 x's on the bottom. What that means is if I'm canceling out pairs of these, I can cancel out 3 of these from the top with 3 out of the 6. Well, if you cancel out 3 out of the 6, you've still got 3 left over. What's cool about doing it this way is notice the x's don't end up having negative exponents. It just is already on the bottom where they're supposed to be. And notice if you cancel everything you had out from the top, remember there's always a hidden 1. So that kind of gets around using the rule, but still gets you the answer, avoids the negative exponents, and tells you where the x is going to land without even having to worry about negative exponents. That's kind of cool. On a test or in your homework, it doesn't matter which way you do it. It's really up to you. Again, like all of these rules, the key is that the base stays the same. It has to match and then it will stay the same. The only thing that should be happening is that your exponents should be changing. So let's take a look at a couple of these. Let's start on problem A. Well, on problem A, we have x to the 5th over x squared. Well, the base does match. The base is just an x, so that will stay the same, and we can do operations because the bases match. When you're dividing, we have a 5 and a 2 as our exponents. What do we do to our exponents? We subtract, which will give us 5 minus 2 is 3. Or If you want to do it the other way, you can. You can say, well, I have 2 x's that I can cancel out of both the top and the bottom. So if I cancel out 2 x's from the bottom with 2 out of the 5, that will only leave me with 3 left over, and that's another way you can come up with your x to the 3rd. Pretty cool. Let's try problem B, which is x to the 6 over x. Well, in this one, again, your bases match. You have x's. The problem is I don't see an exponent on the 1x on the bottom, so you may want to just write that in, which is a hidden 1, because there is technically 1x there. So that means the base will stay the same, the x will stay the same. If you just use the quick rule, which is that you're supposed to be subtracting the exponents, because you're dividing, it's 6 minus 1, which is going to give you 5. If you like the canceling method, that works too. I'd cancel out the 1x on the bottom with 1 out of the 6, which will leave you with still 5 of the x's left, and you still end up with x to the 5th. Let's take a look at C. In C we have, let's see, x to the 8th, y to the 6th over x, y to the 5th. Notice we've got 2 sets of exponents and variables to deal with. We can only do x's with x's and y's with y's, so let's kind of split this up to deal with one thing at a time. So let's deal with the x's. So where we've got the bases matching for the x's, I don't see an exponent on the x on the bottom, so I'm going to put my hidden 1 in. And so when I subtract my exponents, remember my base will stay the same, the x will stay the same, but when I subtract my exponents, because I'm dividing, I've got an 8 minus a 1, which is 7. Or, remember, I can also do canceling out the 1x on the bottom with 1 out of the 8, which will leave me with still 7. That's why I got an x to the 7th. Now let's do the same thing for the y's. We've got y's on the top and the bottom, and again, that means the base will stay the same as a y. Okay. Now let's look at the exponents on these. Well, we have, let's see, a 5 and a 6, so we can subtract. 6 minus 5 is going to give us a 1. Or you can also cancel out. So canceling out the 5 that are on the bottom with 5 out of 6 only leaves you with 1 left. Now, if you type this answer into my math lab, they'll give you some kind of cryptic answer of, you're not wrong, but it's not quite right. And it's because of that 1 on the y. Remember, if we have an exponent of 1, you don't actually have to write it. So they'd rather you not write it. So they'd rather us write this as x to the 7th and just a regular y. And then that's our final answer. Let's take a look at D. In problem D, we've got 9 a to the 4th, b to the 7th over 27 ab squared. Again, let's break this down into parts so we don't get overwhelmed and deal with one thing at a time. So let's deal with the numbers first, kind of get tunnel vision and deal with the 9 over 27. Notice these are not anything to deal with exponents. I don't see any exponents, they're just normal numbers. So if I had the fraction just 9 over 27, what is the problem with it? It's not reduced. So let's reduce it. Well, notice 9 and 27 are both divisible by, I know they're divisible by 3, but I can actually divide out something even bigger. I can divide out a 9 from both. If you did the 3, that would be fine. You just have to divide out another 3 later. You'd still get there. Well, dividing the 9 by 9, I get a 1. Dividing the 9 into the 27 on the bottom, I get a 3. So far, so good. Now I need to look at my variables. Let's start out with the a's. Well, if I start out with the a's, we again have we're dealing with exponents again. So I'm going to go ahead and put my hidden 1 on the a that's on the bottom. So the bases match, so the base will stay the same as in a. And remember, I do what to my exponents? I subtract them. So I've got a 4 minus a 1, which is 3. Or I can cancel them out. The 1a on the bottom cancels out with 1 out of the 4, which leaves you with 3. I really like that method though, because it tells you that the A's land on top. Now it is true that when you subtract your exponents, they automatically land on the top. But this is nicer because it's pretty clear as to where they do land. It's really up to you though. Now with the B's, we've got B's on the top and the bottom. Again, the base, the B, will stay the same. And then you just need to subtract your exponents, which are a 7 minus 2, which will give us 5 B's. Now, you could still do the canceling. That would mean you'd cancel out 2 of the B's from the bottom with 2 out of the 7, which leaves you with 5 left over. So that would leave you with the B to the 5th on top. Again, the way this answer is written is kind of a little bit off. You could write it one of 2 ways. You could hide the 1 because you don't need to write 1s out in front of variables, and you could write it as a cubed b to the 5th over 3, or you can leave the 1/3 the way it is and rewrite your pieces here, the a cubed b to the 5th, off to the side of the fraction. A cubed b to the 5th. Because if something's off to the side of a fraction, it's understood that if you wanted to put it in the fraction, it would automatically go up on top. So either way, and I'm going to show you different ways to write your answers, not to make your life more difficult, but thinking about your final exam, which is multiple choice, you need to be able to know that these 2 answers are the same so that you don't question yourself as to, is this really the same thing as what I figured out? You'll know and you'll be comfortable with that. And my math lab will take either of these answers.